Hello, we're going to go through 1.6, 1.7 practice. So this is going to be very skills driven. We're just going to evaluate a lot of limits algebraically, and we're going to select different procedures to use while we do it. Okay, so the first set of problems I have here are from a piecewise function. And so I just need to make sure I use the appropriate piece for each one. For a lot of these, I'm going to use a direct substitution. So if I want, as x approaches 2 from the left side is going to be, and I'll kind of try to star things, this would be 2 from the left because it would be -4 to 2. That would be less than 2. So if I plug in 2 into that function, I'm going to get 2 squared is 4, 4 minus 5 is a -1. Okay. For number 2, -4 from the right. Okay. -4 from the right. I'm going to use the same function actually. So -4 squared is 16. 16 minus 5. There we go. 16 minus 5 is going to be 11. Okay. And then g of 2, so I just want to know where 2 is. That's actually going to be from the third function because that's where it's equal. So if I plug 2 into that, that will just be a -1. Okay. So, so that's the first 3. Let's see what we can do here. -4 from the left. So that's going to come from the first piece. If I plug in a -4, I'm going to get the square root of 5 minus -4. Which is really 5 plus 4. Square root of 9 is 3. Okay. 2 from the right is going to be the last piece. It's going to be the third one. So if I plug a 2 into there, that gives me a -1. 2 is, so that's a two-sided limit. So we've already, for number 1, question 1, we did 2 from the left. And for number 5, we did 2 from the right. Those do give me the same value. So I do get a two-sided limit does exist, and it will be at the same value at -1. -4, I think we did -4 from the left was 3. -4 from the right was 11. So in this case, this does not exist. And g of -4 does, however, because in the middle we can see that it's equal at -4. So if I plug in a -4 here, -4 squared is 16. 16 minus 5 is 11. Okay. And then last but not least, the limit of g of x as x approaches 0. Well, 0 would be in the middle piece that would fall between -4 and 2. So if I plug 0 in, I would get a negative, excuse me there, 5. Okay. So now we're going to go through the different forms. So we'll stray from piecewise for a minute. I always start with a direct substitution. If that works, then I move on. If it doesn't work, then I need to reduce. So if I do a direct substitution here, this is going to give me a 2 minus 2 squared, which is 2 minus 4, or in this case, -2. Beautiful. Done. Okay. For number 11, if you take a look at the trig notes, anytime I have the sign of a linear expression over another linear expression, it's going to be the ratio of those coefficients. So that's going to give me 2/3. Now, the important note here, please make sure that x is approaching 0 when you use that little trick or that little shortcut. It's very, very important that we do that. Okay. For number 12, I have a quotient, so I'm going to do the limit as x approaches 8 of the top. So x squared plus 2x minus 80 all over the limit as x approaches 8 of x minus 8. If you evaluate the top, it does give you 0. If you evaluate the bottom, it does give you 0. So we need to kind of factor and reduce. So I'm going to take the limit as x approaches 8 of x. That will end up being plus 10 x minus 8 over x minus 8, which will give me the same thing. The limit as x approaches 8. If you reduce, I just have the limit as x plus 10. And if you plug in 8, I get 18. Okay. For number 13, again, I always start with that direct substitution. So this is going to give me the sine of 4 times pi over 8. And 4 times pi over 8 is just the sine of pi over 2. And the sine of pi over 2 is 1. So that would be my answer. Keep going. I have a radical here. So when we have those radicals, the method I'm going to select is going to be the conjugate. So I'm going to I should probably do my indeterminate forms first, make sure it's indeterminate. So let's do a direct substitution. So I'm going to get the square root. I should use proper notation. Hang on. So I'm going to do the limit as x approaches 5 of square root of x plus 4 minus 3 all over the limit as x approaches 5 of x minus 5. And if I do substitute 5 in, I will get 0 on the top and I'll get 0 on the bottom. So now, I forgot my limit. Hang on. Let's write my limit out. The limit as x approaches 5 of square root of x plus 4 minus 3, x minus 5. So now I'm going to use the conjugate, and I'm going to multiply the top and bottom by an x plus 4 plus 3 all over the square root of x plus 4 plus 3. Remember, whatever you do to the top, you have to do to the bottom. And if you do that, when you multiply conjugates together, I'm now going to have the limit as x approaches 5 of the first term squared, which is x plus 4. And then the negative 3 times 3 would give me a negative 9 all over an x minus 5. Do not distribute the bottom. So that gives me the limit as x approaches 5 of x minus 5 over x minus 5 times square root of x plus 4 plus 3. These cancel. So now I have the limit as x approaches 5 of 1 over the square root of x plus 4 plus 3. And if you evaluate at 5, I get 1 over the square root of 9, which is 3, plus 3, which you can leave your answer like that, believe it or not, in calculus, or if you want to combine like terms, 3 would be 9 over 3, so that would be a 10 over 3. I would take that as well. Okay. Number 15. I have a complex fraction, so the method I'm going to select is to get common denominators and then multiply by the reciprocal. So prior to that, though, let's make sure it's indeterminate. I don't want to do all that work for nothing. So 1 over 3 minus 1 over 3x. And then the bottom, the limit as x approaches 1 of x minus 1. And that gives me 1/3 minus 1/3, which is 0 and a 0. Okay. So if I get common denominators, I'm going to have a 1 over 3 times x over x minus 1 over 3x all over an x minus 1. Now I am going to put that denominator over 1 just because it's easier when I have fractions on top and bottom. I'm going to now have the limit as x approaches 1 of x minus 1 over 3x. And I'm going to go ahead and multiply by the reciprocal. And you're going to find that the x minus 1's cancel. So now I have the limit as x approaches 1 of 1 over 3x, which gives me an answer of 1/3. Okay. We got a few more. Number 16, we have the absolute value problem. So, if you remember, we have a piecewise here. So this is going to kind of be, just to kind of show you, I'm also going to factor out the bottom when I do this. This is going to be the negative version when x is less than 5, and it's going to be, over 3 times x minus 5. And then it's going to be the positive version over 3 times x minus 5 when x is greater than 5. Okay? Now, when you reduce these, you can see that to the left of 5 is going to be a negative 2/3, and to the right of 5 is going to be a positive 2/3. So the original problem, number 16, is a left-sided limit. So my answer would be a negative 2/3. Okay. Number 17, let's check indeterminate. So I have the limit as x approaches 5 of 2x squared minus 17x plus 35. Hold on. I wrote really small there for some reason. Let's make this look a little nicer. So I have the limit as x approaches 5 of this all over the limit as x approaches 5 of 5 minus x, which does give me 0 over 0. So if I factor, this is going to be a 2x and an x, and we're going to say, what's it going to be? I'm going to say minus 5 minus 7 all over 5 minus x. Now, I want to cancel these out, but if you notice, they're not exactly the same. So when you cancel this out with the 1 in the denominator, you're going to be left with a negative 1 because it's actually the opposite. So what happens here is I now have the limit as x approaches 5 of 2x minus 7 over a negative 1. And if you plug 5 into that, I get 10 minus 7 is 3. 3 over negative 1 is a negative 3 for my answer. Okay. I think these are the last two, number 18 and 19. So we'll finish this up. So I'm going to say the limit as x approaches 0. And actually, I should probably check indeterminate. Tangent of 0. So sine over cosine. Sine of 0 is 0. Cosine would be 1. So this would be, the top will give you 0, but we have to show it. That's the thing that College Board is really picky about. They want you to show it. So I'm going to say tangent of 3x, even though it's a formality, we're just writing it, over the limit as x approaches 0 of 5x is 0. So now what I want to do is I want to simplify this, and we have trig going on here, so I'm going to try and utilize some of those trig identity stuff that we have. So I know tangent is sine of 3x over cosine of 3x, and that's all over 5x over 1. So what we can do now is we can multiply by the reciprocal as x approaches 0 of, so let's write that numerator out, sine of 3x over cosine of 3x. Oops, I didn't want to close that parentheses. Let's try that again. Times, now the reciprocal of the denominator. And now I'm going to reorganize this. I'm going to say the limit as x goes to 0 of, I'm going to take that sine of 3x and put it over the linear piece times 1 over the cosine of 3x. And now I can evaluate each of that product at 0. I can do a direct substitution. So we know using that trig formula that we had, as long as x is going to 0, that this ratio will go to 3/5 because it's a linear over linear, times, if I plug 0 in, cosine of 0 is 1, so it's 1, so my answer will be 3/5. All right. And last but not least, number 19, we'll go through this. So if I plug in 0, now I'm going to run out of room here, but you should check the indeterminate form. If you plug in 0, you will get a 2h squared minus 5h, and the rest of it goes to 0 all over h. Okay, and actually, I made a mistake here. I'm glad I'm making this answer key. There is a slight mistake. I don't want x to go to 0. I want h to go to 0. Sorry about that, guys. Okay, now I'm going to have a 2x squared. I was wondering. 2x squared minus 5x, and then minus a 2x squared minus a 5x, right? So it'd be plus 5x all over h. You can see that all of this cancels. H is going to go to 0. You will get 0 over 0. So let's talk about how to simplify. Okay, so let's simplify this and then evaluate it. What I have here is the limit as x goes to 0. Now, if you distribute out the x plus h times x plus h, you're going to get an x squared plus 2xh plus h squared. Again, I'm writing it twice, distributing it out, minus, I'm going to distribute this as well. Be careful of your negative. Again, I'm going to distribute the negative into the last piece. And that's my numerator. And that's all over h. Okay, so now I have the limit as x approaches 0. I'm going to distribute the 2 in, so 2x squared plus 4xh plus 2h squared minus 5x minus 5h minus 2x squared plus 5x. You can see here a lot of stuff is going to cancel. More importantly, the 2x's cancel, 2x squareds cancel, the 5x's cancel, and I'm left with the limit as x approaches 0 of 4xh plus 2h squared minus 5h all over h. Now, if you factor out an h from the top and cancel it with the bottom, we are ultimately left with, sorry, these should have been h's. Remember, we wanted to change that typo. I'm going to be left with a 4x plus 2h minus 5. And it won't be over anything, actually, because that h on the bottom cancels out with all the h's on the top. Now, if I substitute 0 in for h, I'm left with the expression 4x minus 5. Again, when you do these problems, you're going to be left with an expression of x and not necessarily a value. Okay? Hopefully that helps you do your homework and kind of go from there. All right?